2.8, solve inequalities in one variable. All right, so some of these are also equalities to start with. The first one say to determine the x values that cause the polynomial function to be 0, positive, and negative. So number 4, f of x is equal to 5x plus 3 times x squared plus 6 times x minus 1. So the easiest thing to find are the zeros, obviously, because we just set this equal to 0 and solve. So I would have zeros at x equals negative 3/5, at x is equal to plus or minus the square root of 6, and at x is equal to 1. Or sorry, the negative 6. Huh?
I was just going to say that, what you just did.
We don't really even need to worry about them because they're not technically going to end up being a 0 because it's not real.
No, that's what I meant, like, it's not 6.
Yeah, I made it negative 6.
Yeah.
Alright, so we're going to have a list of zeros. We're going to have positive. These are going to be intervals. And then we're going to have negative intervals. So my zeros I already know are negative 3/5 and 1. So what I do is I set up a sign chart here with my zeros on it. So negative 3/5 and then 1. So I'm going to choose a number in these different ranges here to see what happens as when I plug those values in. So I'm going to start with an easy one, and I'm going to start in the middle. So if I plug in 0, I don't care what the number equals. All I want to know is in the parentheses, is it positive or negative? So if I plug in 0, is this parentheses going to be positive or negative? Positive. If I plug in 0, is this going to be positive or negative? Positive. If I plug in 0, is this going to be positive or negative? Negative. Positive times negative is? Negative. So we put a negative sign there. So I know that interval is going to be negative. Over here, I would choose something like negative 1. Pick something easy. If I plug a negative 1 in for x, is this going to be positive or negative?
Negative.
If I plug a negative 1 in here, is this going to be positive or negative? I plug a negative in here. Negative. So I have negative times negative is positive. Over here, I would choose 2. If I plug in 2, positive or negative? Positive. Plug in 2 here.
Positive.
Plug in 2 here. Obviously, all positives are positive. So then I'm going to write my intervals, not including, because it can't be positive where it's 0, so it's not including. So this means from negative infinity all the way to negative 3/5, it is positive. Union, over here, 1 to infinity, it's positive in that whole region. So we have 1 to infinity there. Then it's negative between negative 3/5 and 1. So that one is just negative 3/5 to 1. So this right here is your solution.
When would we use a bracket? Do we have to use those in this?
You won't unless we're in inequalities. But these are equalities, so you would not.
Oh, okay, I was confused. Okay.
There weren't notes that were with this, right?
I don't remember. I don't think so, but I don't remember. I think at 2.6, that was the last notes. All right, 6. F of x is equal to x plus 2 cubed times 4x squared plus 1 times x minus 9 to the 4th. So first thing I'm going to do is find my zeros. So I would have one at x equals negative 2. Well, I'm going to do this one in steps because I don't want to lose this. X squared is equal to negative 1/4. So x is plus or minus the square root of negative 1/4. So that one's just going to go away. It doesn't, not doing anything for us. And then x is equal to 9. So my only two zeros that are real are negative 2 and 9. So I'm going to set up my sign chart. So one thing to notice here is as I'm choosing my numbers to plug in every situation, what's going to happen when I plug in a number here?
It's going to be positive.
Why?
Because it's positive, or even squared.
Yep, it's raised to an even power, so in every single case, that is going to end up being positive. So if I want to, I could go ahead and write in a positive for all of those, and then I really just need to look at the other two. But it's up to you. But I just like to point that out, that make it easy. All right, so let's start over here. Let's choose negative 3. So if I plug in negative 3 here, what do we get, positive or negative?
Negative.
And if I plug in negative 3 here, what am I getting?
Positive.
So this whole thing then is negative. In here, 0. If I plug in 0,
No, that's positive.
positive. If I plug in 0 here,
Positive.
also positives. This one's all positive. And then over here, plug in 10, all positive. So sometimes, not always, this happens where you actually get like the same sign back to back. It just depends, but typically because of the type of function, it can like basically just hit and then keep going. It doesn't really like fully turn around. So that's why, but a lot of times you will see them alternating. So just obviously watch for that. Don't just think, oh, they should be alternating, so I got these back to back, so like it's automatically wrong. I would just do a quick check back of your signs and make sure, which is kind of what I was mentally doing there for a second, just to make sure that we were all good. But all right, so then it is positive from negative 2 to negative 9. Or not negative 9, positive 9. Hello. Union 9 to infinity. And then it's negative from negative infinity to negative 2.
Why do we have to do union if it's the same number?
Because 9 is a 0.
Okay.
All right, those are equalities. We'll be back to equalities in a little bit, but in a different form. Next, we're on to inequalities. They say to complete the factoring if needed, because in some cases they are leaving it in its unfactored form, so you might need to factor first, and then to solve the polynomial inequality using a sign chart. So 8, I've got 2x plus 1 times x minus 2 times 3x minus 4 is less than or equal to 0. So these are ones where you could see brackets. Now, the other thing that I'm going to point out to you is rather than listing out where it's 0, where it's positive, and where it's negative, I need to solve the equation to answer the question. I need values that are less than or equal to 0. So, what does that mean? What values do I care about when I do my sign chart? Negatives and 0. So negatives and 0. So I would note that somewhere. so that you don't forget that. And a lot of times the zeros are just going to end up being your capped ends of your intervals. So we still have to start the same way. The setup of everything is the same. We just don't list out zeros, positives, negatives, essentially. So I have zeros at x equals negative 1/2, x equals 2, and x equals 4/3.
So we don't need to do anything with the 2 and the 4/3.
No, those are zeros. So negative 1/2, 4/3, and then 2. So again, I'm checking the signs of what's happening as I plug stuff in here. So I would say probably use negative 1 over here on this side. So if I plug in negative 1, what do I get? Negative. If I plug in negative 1, negative. If I plug in negative 1, negative. So this whole region is negative. All right, in here, I would probably choose 0, probably the easiest thing. So if I plug in 0, what is this?
Positive.
What is this?
Negative.
And this one?
Negative.
So that whole region then is positive.
No, negative.
Positive times negative is positive. All right, over here, this one's going to be a little bit harder. You're going to have to choose something like 5/3 really is your only option of like a reasonable number to put in there. You could technically do, I guess, like 1.5. Like you could do 3/2 there would also work. I'd probably honestly use 3/2 because things are going to cancel a little bit nicer, I think, if I do that. All right, so if I plug in either 3/2 or 5/3, either one's going to work. You can take your pick. That one's positive. What about this one?
Negative.
Negative. This one?
Negative.
So then, wait. This region is positive, or that one's positive. Because 5/3 minus 4, that would be 5 minus 4, which is positive. So this region is negative. And then over here, if I use 3,
Positive.
yep, all positive. So then I would write my intervals. Remember, I need negatives including 0, so I'm going to have brackets except for on infinity. So I'm at negative infinity to negative 1/2. The negative 1/2 gets a bracket. Union, 4/3 to 2, both of those get brackets. So 4/3 and 2. So that would be your interval that solves this. So your answers for the inequality ones are a little different than for the equalities, obviously.
Wait, why don't we have 2 to infinity?
Because it's positive.
Because 2 to infinity is positive. Ten. 2x minus 7 times x squared minus 4x plus 4 is greater than 0.
So now we only want the positive ones?
Yep, so I want positives not including 0. So I would say something like positives only. That would tell me that I only can have parentheses on this. Now, this is one that is not factored all the way, so I need to factor it first. So obviously this first piece is, but I need to factor this second piece. So what is this going to factor into?
X minus 2 squared.
Yep, x minus 2 squared. So then I have to find my zeros. X equals 7/2. And then over here, x equals 2. Sign chart, I've got 2, and I've got 7/2. You can think about it as 3.5 if you need to. All right, what number do y'all want to use to plug in this first region?
0.
Okay, either one works, 0 or 1. What happens if I plug that in here?
Negative.
And over here?
Positive.
Positive. It's a square, so it's always going to be positive on that term. Negative and positive is negative. What?
Do we need to write it twice when it's a square?
No. You're already accounting for that you've done that as you write your sign down.
Okay.
I'm gonna use 3.
Because technically it would be negative squared, so it's becoming a positive. 3? Sure. What happens if I plug in 3?
6 minus 7 is 1 is negative is negative. It's like
Positive.
Negative and positive. And then over here, what number you want to use? 5. Okay, if I use 5, what do I get?
Positive. Positive.
So this region is positive. The only region I care about is positive, not 0. So that means I've got a parentheses on this one. So this one is 7/2 to infinity, not including. All right. We're stepping it up a little bit now. Determine the real values of x that cause the function to be 0, undefined, positive, and negative. If undefined's an option, what do you think we might be getting ourselves into?
Y equals 0. X equals
Eyes.
Failing grade.
What causes an undefined function?
Something defined by 0.
something in the denominator.
Something where 0 is in the bottom. So I'm getting into rational functions.
Someone's failing.
26 f of x equals 2x minus 7 times x plus 1 over x plus 5. So now as I find my zeros, I'm also finding what makes this undefined. So ultimately, I'm going to have zeros. I'm going to have undefined. I'm going to have positives. And I'm going to have negatives. And again, these are equalities. That's why I'm listing everything out. When it's an inequality, we're still just solving it. All right, so what values, let's start with undefined. What values would make this undefined?
Negative
5.
X equals negative 5. It's the only one, so I'm going to note that, or I'm going to have that there. All right, what about 0? What are my zeros?
7 over 2.
Negative 1.
Yep. 7/2 and negative 1. So, pay attention closely here. When I set up my sign chart on this problem, I'm going to put negative 5 on here. But what I like to do is put a slash through it so that I know this is not a 0. Not as big of a deal on equalities, but when I get to inequalities where they are like or equal to and I'm including zeros, I don't want to accidentally include an undefined value. Undefined values can only ever have a parentheses. We can't ever include them. So I like to just get in the habit of putting a little slash through them so I know that I can't include them. And then what do we have? Negative 1 and 7/2. So I'm going to have 4 regions I'm checking now. So over here, if I plug in negative 6, I'm going to set these up as like a fraction bar here. So I'm going to be filling in like the 2 things on top and 1 on the bottom and then figuring out what the whole region is. So if I choose negative 6, what's this first one on top?
Negative.
Negative. What's this one?
Negative.
What about the bottom? Negative.
Base.
Yeah, they all kind of end up looking like faces. All right, so negative times negative over negative is
Negative.
negative. What number do you want to use in here?
0.
Can't use 0 in this region.
-2.
-2. If I plug in -2 up here, what do I get? Over here. On the bottom.
Positive.
Positive. Negative times negative over positive is positive. All right. 0. If I plug in 0 up here, I get negative. Then what? Positive over. So the whole thing is negative.
That one was a war.
Someone slashed his eye.
Number over here?
10.
Sure. What do I get up top?
Positive. Oh, this guy.
All positives are positive. So then now I just need to go write this stuff down. Remember, equality, so I'm not including any of the zeros. They are their own thing. So it is positive from -infinity to -5. Union, -1 to 7/2.
I thought you said we're not.
I just, hold on.
Yeah.
I'm just going to write them in the other place. That was a negative. There. I usually go left to right, and then I get distracted which way I worded them. All right, positives, -5 to -1. Union, 7/2 to infinity.
So when you said we're not including the undefined guy, wait, what?
We're not including any of the undefineds or the zeros. Take your AirPod out.
Oh.
We're not including anything because these are equalities. So zeros are their own thing, undefined its own thing.
What are we not including it in?
The positives, because 0 isn't positive.
Oh, but we do include them in the negatives.
No.
So then why is -5 there?
Everything is a parentheses. That means not including. I don't have any brackets on these.
Oh, that's what not including is. I thought you meant we're just not writing it down.
Oh, no.
Are you slow?
He has at least.
All right.
You said it.
The equalities should be the easiest one, so I'm going to move to the inequalities now. 36. Again, you still may need to factor some of these, possibly. I mean, you may not, but wait. I don't know why I wrote 26. 36. X squared minus 4 over x squared plus 4 is greater than 0. All right, so what values do I care about with this inequality?
Things that are bigger than 0.
Things on top.
Positives only. As far as my answer goes, my answer's written differently with these ones. All right, so I need to first see, I still usually write out zeros and then undefined, just for the sake of seeing it. So, is there anywhere that this is undefined?
No.
And X is.
Correct.
No.
There are none because whatever value it is squared and it's being added to something. There's no way this can be a negative, so there are none. So I'm just going to put a little slash there. I don't have any. What about zeros?
Is X equals
2 and
Yep.
positive or negative 2?
So you could either factor this as a difference of squares to x plus 2, x minus 2, and then find them, or you could honestly just set this equal to 0 and do that, which is probably what you did.
Only the top, right?
Yeah. All right, so these are the values that I'm putting on my sign chart. We will get to one in a little bit with undefined so that we can see what that looks like. Anyways, but all right, so I've got -2 and +2 on here. So again, it might be easier to see this if we rewrite this as x plus 2 and x minus 2. But you can also, this one's relatively easy, so I could leave this here to plug in the values and just say the top is either positive or negative, and then the bottom's either positive or negative. Really doesn't matter. Up to you how you want to do it. But if I plug in, let's say -3, what's going on top?
Positive.
And what about the bottom?
Positive.
So that whole area is positive. What about 0?
Negative.
So that whole region is negative. And then if I plug in 3,
Positive.
positive over positive, so that's positive. I care about positives only, so I'm not including the 0 values on these ones. So that means I'm negative infinity to -2, union 2 to infinity.
So
All right, 38. X squared plus 3x minus 10 over x squared minus 6x plus 9 is less than 0. So first, what values am I going to be looking for when I solve this?
negative, positives.
It's less than, so negatives only.
Negatives.
All right, now this one is not factored, so I need to factor it first. So what would the top factor into?
5 and -2.
X plus 5 and x minus 2. Over, what about the bottom?
X minus 3 squared.
Yep, special type, x minus 3 squared. So now I'm going to use this to find the values. All right, so where is this function undefined if it is?
3.
Yep. When x is equal to 3, because if I plug in 3 there, that ends up with a 0 in the bottom, which is an issue. All right, what about my zeros? Where is it 0?
When x is -5. Yeah, x is -5, x is 2.
Yep. So I'm going to use those two things to help me with my sign chart now. So I've got -5, 2, and 3 going on here, because we include our undefines on our sign chart, but they would not be included if it was an or equal to problem as far as writing our solution down. So I'm still going to put a little slash through here just to remind me that that's an undefined value. Since I'm only looking for negatives, it's not really that big of a deal, but if it was a or equal to, I would want to make sure that I pay attention to that. All right, so using my factored form, what do I know about the denominator?
It's positive.
It's going to be positive every time because it's squared, so I'm going to go ahead and write in a positive in the denominator everywhere. All right, what number do we want to choose over here?
10. Negative.
Okay, -10. If I plug in -10, what happens to both of these on top?
They're going to be negative.
Both positive.
They're both
Negative
so it's
and
positive.
negative. So that's going to be positive over positive. So I get positive. What number do you want to choose in here?
0.
All right, what happens on top when I plug in 0?
It's going to be negative.
Positive, then negative.
Negative.
So that whole area is negative. All right, over here,
2.5.
2.5. What happens if I use 2.5?
Positive.
Positive, positive. So that whole area is positive. And then what about over here?
10.
Sure, 10. What happens if I plug in 10? Positive, positive. So that whole area is positive. So a lot of times around your undefined, it's not going to actually change directions. It's going to stay the same. It's just a value that's not included. So this is a less than problem, so I only care about the negatives. So,
-5, 2.
yep, in parentheses. Now, I just want to show you something. If it was a greater than or equal to problem instead, okay, just go with me for the hypothetical for a second. My answer would be negative infinity to negative 5 with a bracket, union, bracket 2 to 3 parentheses, union 3 to infinity, parentheses on both of those because 3 was undefined.
Is this for, okay, yeah. Is that for less than or is that for greater than?
And
For equal to?
I said if it was greater than or equal to.
Greater to.
I said if this problem was switched and I cared about positives including 0.
Including zeros.
So I said if it was greater than or equal to instead, it was less than. So I changed the problem completely. This would be how you would write your answer.
Okay, thanks.
So if the problem is less than, we're only finding negatives. If it's greater than, we're only finding positives. But if it's equal to, you find both.
Well, if it's or equal to, like if it's like we didn't end up with one that did this, but if it's greater than or equal to or less than or equal to, we include 0.
And positive and negative.
Well, it depends on what it's asking for. If this sign instead was greater than or equal to, this would have been my answer.
Yeah.
This was less than, so this was my answer.
Yeah.
If it was less than or equal to, these would have been changed to brackets.
That's right.
I get one.
All right. Any other questions on these?
No.
All right. Problems 3, 9, 25, 33, 37, 39.
Yeah, I need to get a new notebook.
45.
may use the restroom.